So this is section 7.1, the greatest common factor. So greatest common factor is very often abbreviated GCF. But here's how I think about the greatest common factor. The GCF is the biggest thing that they all have in common. The biggest thing that they all have in common. So when I say they have it in common, I mean they're all divisible by it. So it's the biggest thing that they are all divisible by. Let me show you what I mean with this example. So we've got 28p to the fourth, and then we've got 44p squared q. Now I'm going to give you an overview, and then we'll go through exactly how to solve it. So the first thing I do is I think about what do they have in common? What are they both divisible by? And I might start by saying, well, they're both even numbers, which means they're definitely both divisible by 2. So I could start by saying, well, my GCF probably has a 2 in it. This is just an overview, so this is not how you would pin down exactly the GCF, but it is the idea. They're both divisible by 2. Now, they're actually both divisible by a little bit more than that. And if you think about it for a minute, you might say, actually, they're both divisible by 4. 28 divided by 4 is 7, and 44 divided by 4 is 11. So they're both divisible by 4. So my GCF should actually have a 4 in it. Then I'm going to move on to the letters. This one has 4 p's in it. It's p times p times p times p. This one has 2 p's and a q. And let's see, well, they have at least 2 p's in common. So I'm going to write that. They have 2 p's in common. That's just p times p. It's totally okay to write that as p squared, p times p, either one. But they have 2 p's in common. I can't write more than that because this one only has 2. They have no more than 2 in common. So this is actually the answer to this problem, but let me show you the way to be very thorough about it, to make sure that you got everything. To make sure you got everything, you factor both expressions. So I'm going to start by factoring 28. Well, 28 is divisible by 2, and if I divide it by 2, I get 14. And then I know 14 is also divisible by 2, and if I divide it by 2, I'm left with 7. 7 is a prime number, so I'm done. It's factored. With 44, I can do something very, very similar. I know it divides by 2. If I divide it by 2, I get 22. And then again, 22 is divisible by 2. And if I do that, I'm left with 11. So I have factored it. Let me write now the factored version of these two things. So 28 is really just 2 times 2 times 7. And p to the fourth, we did this above, but it's p times p times p times p. This is the fully factored version of 28p to the fourth. They're all multiplied together. I'm going to do that with 44 as well. 44 is 2 times 2 times 11. And then it's times p times p times q. What you can do now is just make sure that your GCF, your greatest common factor, has one of everything they have in common. So let me give you an example. They both have a 2, so I'm going to cross it off and I'm going to write 2. And then look, I see another 2. They both have another 2, so I'm going to write another 2. I cannot do a 7 because this guy does not have a 7. And I cannot do an 11 because this guy does not have an 11. So they don't have a 7, they don't have an 11 in common. They do have a p, so I'm going to cross off one of the p's and write a p. But then look, there's another one. They have a second p in common, so I can write a second p. Now there are no more p's over here, so I can't add any more. I'm done. And there is no q over here, so I cannot add q. So this is the final answer. I have listed all the factors. You can simplify this just by multiplying together. 2 times 2 is 4, and p times p is p squared, which is exactly what we got up above. So as time goes on, you're going to get more and more comfortable just kind of looking at it and thinking to yourself, what are they both divisible by? And you might be able to just write the answer right away. But if you're uncertain or you want to go through the full procedure, this is how you do it. You factor everything and then you write down all the factors that they have in common. Let me give you one example of how we might use this. So this says, please factor the following expression. 25m to the fifth minus 45m cubed n minus 45m n to the seventh, which looks overwhelming, but don't worry. The more expressions actually, the easier factoring this can be, because what we're looking for is, what do they all have in common? Every single one of them needs to have it in common. The first thing that comes to my mind when I look at all these numbers, 25, 45, and 45, is that they all end in 5. So they're divisible by 5. So I'm going to take out a 5. The other thing that I notice is they all have an m. This has 1 m, this has 3, and this has 5. So at most, they have 1 m in common. Now, to be sure, what you could do is factor each and every one of these and do this procedure where you cross it off and then you write down each one that you crossed off, and you can only cross it off if they have it in common. And that would give you the GCF. But I'll just tell you, if you did that process, you would get that the greatest common factor is 5m. Once you have the greatest common factor, here's what you do. You're going to write down 5m, and you're going to take it out. So I'm going to take out a 5m from this guy. I'm going to take out a 5m from this guy, and I'm going to take out a 5m from this guy, and I'm going to write down what's left. And when I say take out, I really mean divide. So I'm going to divide everything by 5m. So let's see. Well, 25 divided by 5 is going to be 5. And if I take out an m, there were 5 m's, there will be 4 left. I'm going to do the same thing for the next guy. Negative 45, I'm going to divide it by 5. That would give me negative 9. And then if I take out an m, well, right now there are 3 m's, so there will be 2 left, and the n will be left. And then same thing over here at the end. It's a negative 45 m into the 7th. Negative 45 divided by 5m is going to be negative 9. And then I'm going to take out that m, so it's gone. And what I have left is n to the 7th. Now we are finished. This is our final answer. But if you want to check your work, here's how you can do it. To check your work, all you got to do is take this expression right here, our final answer, and you distribute. If you get back to where you started, you did it right. So I'm going to distribute this 5m to all 3 of these. If we get our original expression, we did it right. So let's see, 5m times 5m to the 4th, well, that would be 25, and then we combine our m's, and we get m to the 5th. Then for the next one, I do 5 times negative 9, well, that's negative 45, and then m times m squared is going to be m cubed n. And then same thing at the end, 5 times negative 9n to the 7th. Well, that's negative 45. And then there will be an m, nothing to combine it with, so it just stays. And then n to the 7th, which is exactly what I started with. So that means I have done it correctly. So this is, in fact, my final answer.